Alright, good afternoon, calculus class. So this one is for the lesson of section 3.6, derivative of logarithmic functions. So some of the formula that I need to recognize here, derivative of natural log of x is 1 over x, or derivative of natural log of absolute value of x is 1 over x. And then log base a of x is considered 1 over x times natural log of a in the denominator. And then derivative of natural log with the chain rule. So derivative of natural log of u is considered 1 over u times u prime, or du over dx. And also the derivative of natural log of g of x is considered g prime of x over g of x. Because derivative of natural log of a quantity, it's 1 over the quantity. So it's 1 over g of x. And then times the derivative of the inner functions, which is g of x. So then that'd be g prime of x. So now we'll take a look at that, some of the examples, the way to apply the formula for the natural log derivative and also the regular log base a of x. So the first one, so f of x equals natural log of sine square of x. So again, anytime they see the unit function, you want to say that's u. So u equals sine square of x, or sine of x quantity square. So that means u prime is like 2 sine x cosine of x. So we write it in terms of u for that f of x. So we do have natural log of u. So that means f prime of x, it's considered 1 over u times u prime, or du over dx. So using that formula. And then what we got right now, so it's 1 over u, unplug everything. So u, which is what, sine square of x, or sine of x quantity squared, depends on which way that you prefer. And then times u prime, so u prime, which is considered 2 sine x cosine x. And for those you might be wondering, can I reduce? Yes, certainly you can do that. So we do have 2 cosine of x over sine of x. So 2 cosine of x over sine of x. In other words, this one is what? 2 cotangent of x. We tried to reduce it or simplified it using the identity. And now what about for part B, compare and contrast? So this one obviously is the first one, so the base is a. Can always do it this way. Again, inner function, instead of using x e to the power of x, you can say that this one is u. So using that, the product rule to find out u prime, then u prime would be considered 1 times e to the power of x plus e to the power of x times x. And then rewrite it using that log base a of u. So this one is written as, well, for y prime, then that would be considered 1 over x, which is 1 over u, times natural log of a. And don't forget about that times u prime, because that's the implicit differentiation or the chain rule. And then the rest of this, we just need to unplug everything. So 1 over u, so u, which is what, x, e to the power of x, times natural log of a, times natural log of 5, and then times u prime. So u prime, this one is just the quantity of what? 1 times e to the power of x, which is e to the power of x, plus x e to the power of x. Just like that. And for those who might be wondering, can I just cross out that e to the power of x down here? Because that's the common factor. Certainly you can do that. Okay, so try to simplify it a little bit more. Okay, let's just bring it down here. So we do have e to the power of x, and then times the quantity, 1 plus x. So this one, we just take out the greatest common factor. And then denominator, we do have e to the power of x, that means we can reduce. So eventually, so this one is 1 plus x over x times natural log of 5. Okay, so just like this. So for those who would like to reduce it, try to simplify it a little bit more. Yeah? What about for the test? Do we need to reduce it all the way through? Yes, please do that. Make sure that got to be the simplest form, the lowest term. And now what about for C and D? So for C and D, they're quite similar. So one is involved with natural log, the other one involved with natural log of the quantity with the base e. Okay, so one thing that you want to do, so set up u, which is 1 plus natural log of t, and then w, 1 minus natural log of t. And the reason why that is because this one involved with 2 different forms, 2 different functions. So u prime, then that would be considered 1 over t. And then w prime, then that would be considered 1 over t also. Okay, so now let's find out. So it looks like the structure here, it's written as u over w using the quotient rule. So using the quotient rule, we do have f prime of t, which is considered u prime times w minus w prime times u, and then over w squared. And now you want to substitute, so f prime of t. So u prime, so what we got here is 1 over t times w, 1 minus natural log of t, minus w prime, it's also 1 over t, but this 1 times u, so which is 1 plus natural log of t. And then denominator, what is it? It's over w squared, so 1 minus natural log of t, quantity squared. And for those you might be wondering, can I cross out that 1 over t? 1 over t. Well, once you separate it out, yes, you can do that. But make sure that you need to put in with the... okay, so when it's negative, the other one is also negative. So try to distribute. So once you distribute, so it's 1 over t minus 1 over t, natural log of t, minus 1 over t plus 1 over t, natural log of t. All over 1 minus natural log of t, quantity squared. So this one got canceled. What about those two? Looks like they all got canceled here. Okay, so just let me check that. So it looks like everything's gone. So u, w, u prime. Oh, you know what? This one's supposed to be negative because I have negative sign. So gotta be careful with that. So w prime, this one's supposed to be negative. Okay, positive, negative. So w prime, so once you plug in that, this one is supposed to be negative 1 over t. Okay, so let's just repeat that part right here. So after you distribute, because that would be kind of weird if everything got canceled, it turns out to be 0. It's not a constant, it's just a random function. So it's 1 over t minus 1 over t, natural log of t, negative, negative, positive, so plus 1 over t, and then negative, negative, positive. So this one would be positive natural log of t times 1 over t. So actually those two, they got canceled. But 1 over t plus 1 over t, that would be 2 over t. Okay, just the numerator. And then the denominator is considered 1 minus natural log of t, quantity squared. Just like that. Another way you can rewrite it, it's like 2 over t times 1 minus natural log of t, quantity squared. Denominator, just put them all together. So now, what about for part D? So this one involved with y, and then e to the power of y. So using that implicit differentiation strategy, so this one f prime of y, using the product rule. So we got y prime times natural log of 1 plus e to the power of y. Okay. And then plus derivative of natural log of the quantity, and that'd be 1 over 1 plus e to the power of y, times the derivative of the inner function, e to the power of y times y prime. Oh, you know what? Y is the variable, so we don't need to put in y prime. So y prime is just considered 1. Yeah, normally y is the dependent variable, but y, this one is the independent variable here. So just 1 times natural log of 1 plus e to the power of y, plus 1 over 1 plus e to the power of y, times e to the power of y. And now let's see what else that we can do. Maybe we can combine them together, or we can just leave it like that. Okay, just leave it like that. Okay, so now let's see what else that we got for the rest of this. Again, it's all about using formula, derivative of natural log, or LOG. Okay, so now what about things that's getting kind of complicated and crazy? Okay, so this one, obviously we can use that the property of natural log. I mean, you can use that the inner functions out of the function, but that would be kind of confusing. So one thing we noticed, so natural log of z, this one can be written as natural log of a squared minus z squared over a squared plus z squared. Just rewriting it. to the power of 1/2. Now back to algebra 2, some of the property that you need to know. If you see that the natural log of x times y is considered natural log of x plus natural log of y. Product to sum. If you see anything like quotient, x over y with the natural log, this one can be expanded as natural log of x minus natural log of y. And then for the power, if you see the power, so for the power, the exponent, you can bring it down to the front as a coefficient. So power to coefficient. So for the 1/2, that's a power. We can always bring it to the front. Another thing that we can do before we differentiate it, as you can see that the inner structure here, it's a quotient. So we can use that the quotient's two different property. So basically just expand it. So natural log of a squared minus z squared minus natural log of a squared plus z squared. So once you expand it, so we can distribute that 1/2, and then it's easier to differentiate it. So it's 1/2 natural log of a squared minus z squared minus 1/2 natural log of a squared plus z squared. Keep that in mind, z squared, so z is the variable. So for this one, you probably want to say that using w, u, and w, you can do that. So u would be what? A squared minus z squared. So u prime, which is negative 2z, because a is a constant. And then w, then that would be a squared plus z squared. So w prime, then that would be 2z. Rewrite it, so this one is considered h of z. So that equals 1/2 natural log of u minus 1/2 natural log of w. And then differentiate it from here, so 1/2 1 over u times u prime minus 1/2 1 over w times w prime. And then for the rest of this, we just want to substitute. So 1/2. So u, which is 1 over a squared minus z squared. U prime, which is negative 2z times negative 2z. 1/2. 1 over w. A squared plus w z squared. A squared plus z squared right here. And then w prime, which is considered 2z. The 2 cancel. So what's left here? It's just negative z over a squared minus z squared. And then minus z over a squared plus z squared. That's the final form. Again, it's all about using the properties of natural log. So once you expand it, it's easier to differentiate it by using the UW substitution. Okay, so now what about for f? That one is quite similar. Okay, so inner function, we can just set that as what? U. So instead of using UW, this one just use one singular variable. So U equals e to the power negative x plus 2x e to the power negative x. Now this one you cannot expand it because that's the inner product, the inner quantity, that's a sum. There's no way you can distribute the natural log. You don't want to do that, okay? That would be something else. So u prime, then that would be considered derivative of e to the power negative x, the same function, times derivative of negative x, negative 1. And then this one using the product rule, so derivative of 2x, 2 times the second function. And then derivative of e to the power negative x, e to the power negative x times negative 1, chain rule. And then times 2x. Again, rewrite it. So y equals natural log of u. So y prime, then that would be 1 over u times u prime. So it's 1 over the original function, e to the power of negative x, plus 2x, e to the power of negative x. And then u prime, which is this one right here. So let's see that if you try to combine it. So negative, positive, so that'd be e to the power of negative x. Because once you combine this together, then that'd be e to the power of negative x. And the other part right here, so just carry that over. Negative minus 2x. Negative times positive, negative. So negative 2x times e to the power of negative x. And also for those who might be wondering, can I take out that e to the power of negative x so we can cancel them out? Yes, certainly you can do that. So once you find out the derivative, normally there are a lot of things you can cancel. The greatest common factor, that's one of them. So the top part, just call negative e to the power of negative x. So we got 1 minus 2x. Denominator, take out e to the power of negative x. So we got 1 plus 2x. So eventually, we have a rational expression, in which is the derivative of the original function. Okay, so now what about finding y prime, y double prime? It's the same strategy. So instead of using that UW substitution, we can simply using the quotient rule. So using the quotient rule, so y prime, derivative of natural log of x, 1 over x, times g of x, x squared, minus derivative of x squared, 2x, times natural log of x, all over x squared quantity squared, x to the power 4. And then the rest of this, reduce, so then that'd be x minus 2x natural log of x over x to the power 4. And as you can see, that x-axis, so we can just cancel out the x, reduce down to 1, x to the power 3. So this one's gone, that means 1. So it's 1 minus 2 natural log of x over x to the power of 3. But now we need to find the second derivative. So now from here, so we want to differentiate it again. So that's a lot of work here. So differentiate it, so using the quotient rule once again. So derivative of the top. Okay, let me just put it back up here. So y prime, we do have 1 minus 2 natural log of x over x cubed. So y double prime, derivative of the top, then that'll be negative 2 over x. Because derivative of 1, that's just 0. And then times the denominator, minus derivative of the denominator, 3x squared, multiplied by the top function, using the quotient rule, all over the denominator quantity squared, x to the power of 6. Cross cancel, so this one turns out to be negative 2x squared, minus 3x squared, distribute, and then plus, let's see what else, plus 3x squared, no, plus 6x squared, distribute, natural log of x, all over x to the power of 6. Combine those like terms. So we do have negative 5x squared plus 6x squared, natural log of x, over x to the power of 6. Another thing that I can do, reduce. X squared, x squared, x squared. So 6 minus 2, then that'd be 4. So what we found here, it's negative 5 plus 6 natural log of x, all over x to the power of 4. And that'd be the second derivative. So once you get familiar with the structure of the quotient rule, you can always do it directly. Okay, so now what about for part B? So part B is quite similar, so using that U substitution, because at the inner function we do have the trig expression secant x tangent of x. Okay, so this one, let's say u equals secant x plus tangent x. Again, you don't want to expand it. There's no such property for sum to product to expand this one. That's not the valid property. Okay, so what we got here, u prime, then that'd be secant x plus tangent x. Derivative of tangent x, then that'd be secant square of x. So this one, rewrite it. So y equals natural log of u. So derivative of natural log of u is always 1 over u times the chain rule, u prime. So y prime, then that'd be 1 over secant of x plus tangent of x. And then the top here, we can just pull something out if you want to. This one can be written as, take out secant x. So we do have tangent of x plus 1, plus secant of x. So this one is secant x times the quantity of tangent x plus secant x. So basically what I did here, just factor a little bit for the u prime. And as you can see that this one can cross cancel. So eventually for y prime, guess what that is? You just secant of x. Alright. And now, what about things that's getting crazy and complicated, and that looks like it's impossible to differentiate? Again, it's all about using the structure, the one that we put in for the properties of natural law. Okay, so let's try all of them. Okay, so the first one, I try to expand it. So what I can do, what happens if I take the natural log for both sides? So once you take the natural log of both sides, so basically the right hand side, you can expand it. So it's natural log of y. Okay, let me get more space here. So basically you can expand it all the way through. So once you expand all the way through, you'll see that it's term by term. So once we get back the polynomial with term by term, it's easier to differentiate. So the first one, take the natural log of both sides. So we have natural log of y. So that equals natural log of x to the power 1/2 plus natural log of e to the power of x squared plus natural log of x squared plus 1 to the power of 20. So what I did here, just using the properties of product to sum. So let's say we do have x times y times z with the same natural log. You can always expand it into natural log of x plus natural log of y plus natural log of z. And now what about the power? You can always bring it to the front. That's what I told you earlier, the one that I showed you earlier. So you see the power, r, you can always bring it to the front. So it's 1/2 natural log of x plus x squared, because natural log of e, that's just 1. And then plus 20 times natural log of x squared plus 1. Again, you see that natural log of e, that's just a basic property for natural log. It's always 1. So once we come up with all this, once we simplified it all the way down, so we can take the derivative. So derivative of natural log of x, that's 1 over x times 1/2. Derivative of x squared, 2x, power rule. Coefficient, bring it down. Derivative of natural log of the quantity, 1 over the same quantity, x squared plus 1. But don't forget, this one's kind of like u. Derivative of the inner function, 2x. And now what else can we do from here? So multiply them straight across. This one, just leave it. And this one here, it's just what, 40x over x squared plus 1. So that eventually is going to be the derivative on the right hand side. Now, what about the derivative of the left hand side? So derivative of natural log of y, it's 1 over y times y prime, the chain rule. So now you want to solve for y prime. Guess what you need to do? Multiply both sides by y. Okay, so once you multiply both sides by y, you can cross cancel. So eventually, it's going to be written like this. So it looks like this one is just a derivative, but don't forget, we need to multiply by y. So that would be y prime. So y, that means just the original function itself. Okay, so now let's try the next one and see what happened. Again, using all the properties. Okay, so this one, let me just erase it. So part B, so this one is quite similar to the one we did earlier, using the properties of natural law. Okay, so that one, it's almost the same kind of setup. So natural log of y, both sides, so 1/4, rational exponent, and then expand it. Okay, well, let's just rewrite it first. So natural log of x squared plus 1 over x squared minus 1 to the power of 1/4. Again, 1/4, you can just bring it to the front. And then for the natural log, we can expand it, x squared plus 1. Natural log of the quantity, x squared plus 1 minus natural log of the quantity, x squared minus 1. Again, take the derivative, so the one on the left hand side, so it's 1 over y times y prime. And derivative of this, again, this one is just like u. So u prime, then that'll be 2x. So using the chain rule, so 1 over that quantity, x squared plus 1 times 2x. But don't forget about the 1/4, that's part of it, because that's a coefficient. Normally we put it right in front. And then minus Okay, because that 1/4 you want to distribute, so it's 1/4 here also. Derivative of this, so let's say this one is w, so w prime, then that'd be 2x. So that'd be 1/4 times 2x over x squared minus 1. So therefore y prime, so that equals x over 2 times the quantity, x squared plus 1, minus, again this one's just cross cancel. So x over 2 times the quantity of x squared minus 1, and then this whole quantity times y. Okay, so that's a lot of quantity here. Times y. Again, that would be the final derivative. So now, what about for C and D? What happens once you deal with the power with the variable? Similar situation. We're using that the power to coefficient property. Okay, so for C, okay, let's check that out. So again, using that in natural log property, so y equals x to the power square root of x to the power of x. Well, basically this one is like a power property, so it's x to the power 1/2 to the power of x. So in other words, written as x to the power 1/2 x. So in order to drop down the power, so what we can do, take the natural log both sides. So bring down the power 1/2 x times natural log of x. And guess what we can do from here? The right hand side, guess what we have to use? That's right, the product rule. So 1/2 derivative of 1/2 x, which is 1/2, times the second function, plus the derivative of the second function, derivative of natural log of x, 1 over x, times the first function, 1/2 x. And then the one on the left hand side, derivative of natural log of y is 1 over y times y prime, chain rule. Things that we can simplify on the right hand side, so which is what, 1 natural log of x over 2. And then plus, well, x got cancelled, so we got what, 1/2 y prime, so that equals what, this whole thing times y. Okay, so it's pretty straightforward. And then the last one is quite similar, so y equals sine of x to the power of natural log of x. So in order to bring down the natural log of x, we take the natural log on both sides. So natural log of y equals natural log of x times natural log of sine of x. Okay, like that. Again, product rule on the right hand side, derivative of natural log of x, 1 over x times natural log of sine of x. And then don't forget about the natural log of sine of x, derivative of that, it's 1 over sine of x times the derivative of sine of x, which is cosine of x. And then times the first function, because that's the product rule. Cosine over sine, which is what? Cotangent. Derivative on the left hand side, 1 over y times y prime. So eventually it's y prime equals natural log of sine of x over x plus cotangent of x times natural log of x, and then this whole quantity times y. Okay, so the last one, it's a little bit complicated because I have the second function that involved with the inner function. Okay, so that's it. So make sure that you guys need to rewind or fast forward or just focus on the one that you guys need more time to study, the example that we went over. Okay, so thank you for watching the video today. So I'll see you guys next time. You guys take care. Bye.